Yeah, hello, hi everyone. Next, uh, this is the one of the question Qualcomm asked. Qualcomm, uh, how to handle two I2C buses with different speeds in a device driver. In I2C bus, it's having two different speeds. One is a 4 kilohertz and one is a 8 kilohertz. How to handling the buses in a device driver? For that. Yeah, when you're working with the two I2C buses operating different speeds, you can need to configure each I2C controller appropriately. You need to control the two I2C buses it's appropriately. Then only it's a communication. It's a better way. So some approaches handling two different I2C suites. Like first, I'll give normal introduction. Then I'll go to the deep. First, I2C identify the I2C controllers. First approach is identify the first I2C controller. E Linux assign I2C controller to I2C 0 and I2C 1. It's like that. First, you don't to identify the I2C controller, and then each controller can be configured independently. This is the one, and other one is a configure the speed of each bus and set the clock speed during the initialization only, and then speed typically configured using device device tree and platform data or SysFS. By using that, you can configure the speed, clock speed, and during the initialization itself you can change, you can give into. And next, handle transaction with current bus and select the correct I2C bus for each transaction, and ensure speed settings are applied correctly before communication. This is the one approach. These three approaches we can handle the different speeds I2C. First, yeah, first approach, device tree configuration for different I2C speeds. If you if your platform support device tree, means it's a platform, your platform whatever you are implementing is a driver, its platform is supporting device tree. Set the speed of each device, each I2C buses, means it's like it's by using I2C core driver, read the settings and configure respective controls. Means after device tree setting, it's a I2C core driver, read these settings and configure respective controllers. So here we are setting like I2C, it's a clock frequency 400 and status okay, it's a like, and I2C2, it's a like I2C1, it's like clock speed is means we modifying the device tree and uh, then I2C core driver read the particular settings and configure respective controller. This way we can control the I2C speed, two different I2C speeds we can control, and configure the I2C speeds in device driver. If the speed is not set via device tree, you can configure it dynamically. Means it's second approach. Device tree it's not supporting, and that case you can go through the you can configure dynamically in your driver. Set the I2C speeds using I2C set adapt data. Means here we are this is the one is the adapt to probe my driver I2C probe. We are in the one of the structure, it's like I taken, it's like I2C adapt to so here first we can making setting up with 4 kilohertz and 8 kilohertz. Just with conditions where if the I2C speed is first one, it's executing to the first, and next one it's executing to the next. So you are writing the if condition, and it's configured to dynamically for your driver. This is the second approach. Means first approach is via device tree it's not possible, set the device tree, you can configure dynamically in your driver, setting up by using I2C set adaptive function. Okay, this is the one approach, and otherwise alternate approach, dynamically change I2C speeds via SysFS. By using SysFS we can change dynamically in runtime. Uh, we can change the speeds in runtime and modify I2C driver at runtime. First one, this is by using sysfs we can change the speeds, or otherwise modify I2C driver at runtime using same I2C set adapt to data dynamically. Modify the clock set register directly if they have common I2C controller. This is the approaches. First one, it's like device tree. Second one is we can changing to the dynamically by using I2C set adapt to data, and this is alternate approach by using sysfs we can changing to the I2C speeds dynamically, and same I2C driver runtime, it's the same, it's a function using, and modify and register the clock driver. And conclusion, so here device tree is the best way to define I2C speed at boot time. Actually, when the boot time is a device tree is the best way to boot time. But if not supporting, if not platform is does not supporting to the device tree, but to set the speed set dynamically in the driver. Means if not supporting what your platform or your whatever you are using platform, you is not supporting. Uh, you are using to dynamically you can setting that driver, and each I2C bus it's operate independently, so applies the speed settings before transaction only we can set it. By using sysfs provide way to change to the speed at runtime if support the driver. So these are the some points we can uh, communicating to drivers to I2C buses easily. Uh, Thank you. Uh, like, share, subscribe. This is the one recent Qualcomm question, like how to handle handle two I2C buses with different speeds in in device driver 4 kilohertz and 8 kilohertz. How to handle it? This is the flow. Can you go through that? Thank you. Thank you for watching.